Hello, great minds. In today's lesson, we have an exponential equation to solve. And just before we go right into solving this equation, I'd like to know what method do you think we can apply to solve for x in this equation? And secondly, can you solve for x by inspection? Please let me know what your thoughts are in the comment section. Yeah, thank you. So we're given that 5 to the x is equal to x, and we are about to find the value of x that will satisfy this given equation. Of course, for this equation to be true, it implies that x has to be positive, right? Yeah. So the next natural thing I need to do from here is to take the natural logarithm of both sides. So I take the ln of 5 to the x, and I also take the ln of x in the right-hand side. Perfect. Now, from the laws of logarithm, if I have log a to the n, I can further write these guys as n log a. I mean, as if to say the n will just fall behind the logarithm, then you have n log a. Very true. So applying that concept right here, we're going to have x ln of 5, and that is all equal to the ln of x. So just before we continue, ln is a logarithm with a base e. So ln is just still a logarithm, but this time it's having a base e. That's why it is a different kind of logarithm. So we call it natural logarithm. So the laws of logarithm still applies to the natural logarithm. Okay, perfect. So, and again, before we continue, it's still just important you know that if I have exponent ln of x, this is the same as x, because you know ln is the same as log base e. That could be now be further expressed as log x base e. And you know the exponent will take care of the log e, so we have now x. That is why exponent log x is the same as x, right? Perfect. So to move forward from here, I would like to take the x to the x, and to achieve that, I divide everybody by x. So this x cancels out this x, so I have ln of 5 is all equal to the ln of x upon x. Yeah, perfect. We are moving forward. Now, the next thing we need to know from here is we are about to apply a function which is called the Lambert W function. And what is even the Lambert W function, and when do you even apply the Lambert W function? If I have maybe, let's say, an expression here like a to the e, ae to the a, this e is exponent, okay? If I have this kind of expression, if I go ahead and apply the Lambert W function right here, okay, I'm going to get a. That's interesting, right? So before you apply the Lambert W function, you must make sure you have this kind of setup. That's where it works. And that is what we are about to do. So you just watch as we continue. Now, remember we said earlier that we can write x as exponent ln x. I need to introduce exponent into this equation because I need exponent for the Lambert W function to work. So introducing exponent, I'm going to rewrite x as exponent ln x. So here I have ln x upon exponent ln x, like this, right? It's still the same as x. Okay, we haven't really changed anything from here. And of course, from the laws of exponent and from the laws of indices, if I have 1 over exponent x, it's the same as exponent minus x, right? So from here, I'm going to write these guys as ln of x times exponent negative ln of x, right? So let me just take care of these guys right here. 1 second, please. Perfect. So to this very point, we are almost close to the solution. We still have the ln of 5 in the left-hand side, and that is now equal to the ln of x times the exponent negative ln of x. So to this point, I'm very sure it's clear. Now, the next thing you want to do here, like you know, you need to have the same value. I mean, the a here has to be the same a right here. No sign, no difference in sign. So you can see right here, we have a negative ln of x, and right here we have a positive ln of x. So what we need to do is to multiply both sides by -1 so that they both look the same. So when I do that, I'll have negative ln of 5 is equal to the negative ln of x times exponent negative ln of x. Now, at this very point, they are looking exactly the way we want it, okay? Now, we can now go ahead and apply the Lambert W function, right? And so if I apply the Lambert W function for this equation, I'm going to have ln of 5 right inside this box, and apply the Lambert W function for these guys. I have negative the ln of x times negative ln of x. So what do you think would be the result when you apply the Lambert W function? Of course, just like we've explained earlier, the Lambert W function of a exponent a will just give us a. So that will just give us negative ln of x. Okay, and right here we still have the Lambert W function of ln of 5. Let's just put 5 like this without the bracket inside again. So I hope it's looking very cool right now. It's looking very cool. So I can go ahead and clear off these guys from here, guys, so that I have enough space to just solve this problem completely. So from this point, I'd like to write negative ln of x like this. And that is now equal to the Lambert W function of negative ln of 5. Perfect. Now, I'm about to get the value of x. And I need to take away this negative sign from here. So if I multiply both sides by a negative 1, so I'll have the ln of x is equal to the negative Lambert W function of the negative ln of 5. Now, I need to get ln out of this position. And how do I get this ln out of here? I need to just take the exponent of both sides. So when I take the exponent of this guy, I take the exponent of this guy. Of course, like I told you, exponent ln s will give us x. The exponent take care of the ln, so we now have x. And that is now equal to negative Lambert W function of negative ln of 5. You can further express this guy as 1 upon the exponent of the Lambert W function of the negative ln of 5. So this is just the value of x. You can go ahead and put this in your calculator, or you can go ahead and put this in Wolfram calculator on the internet, and I'm very sure you get the real value for x. So we've come to the end of this particular video. Did you get the same solution as I? Let me know in the comment section. And thank you for watching. See you in the next class. Bye-bye, and God bless.